So yeah, for those of you who aren't aware, Redis Lab is the open source home of Redis, as well as the enterprise provider. We offer both cloud and a full-fledged enterprise version that gives you easy scaling, high availability, the ability to have multi-tenant, multiple databases running in a single cluster, all out of the box with just a few clicks and a bunch of extra fun optimizations as well. If you're interested in that, we have a booth outside, as well as our website. Happy to give you a demo. Blah, 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 blah. But that's not really what I'm here to talk about. I just need to give that word so my VP is happy with me. I'm really here to talk about Redis. So, show of hands, how many of you guys have Redis running in production right now? Okay, handful. How many of you have never really heard of Redis or never really used it at all? Cool. So really I'm going to talk to the full spectrum. And hopefully if you're a Redis expert, you're going to learn a couple things. If you're completely new to it, you're going to learn a whole lot. But the general idea is that Redis is a data structures database. I often refer to it as memory as a service. So that means you can have n number of servers sharing a memory pool. And it can be very, very complicated and high scale data structures using the primitives that are available. And for those of you coming from a SQL background, here's a very, very simplistic definition. You have keys, you have values, and those values are really not just a string. You can really have, you're going to have lists and sets and ints, all kinds of different things. It's open source. You can go out, check it out off of GitHub, and work with it. And then, of course, like I mentioned, we offer a managed cloud version. It's very simple, and then an enterprise version as well. So here's a quick overview of the different data types available. Like I said, you got strings and lists and sets, and for all of you who know how to program, these should look very familiar. It's based on trying to not force you into a specific paradigm. So other databases force you into a document model, force you into a table, and here you have the ability to essentially think the same way you would as you build out any given kind of program. And just like any programming language, you can use these as building blocks to build very, very complicated or very simple applications. So why would you use it? Because it's really fun, and it's easy, and it's scalable, and I might have mentioned already, it's really fast. It's been used by a bunch of different companies up there. I already mentioned Twitter. And yeah, it's very well known at this point, hence why you all are here, hopefully. But I really like it because it makes you think. It's not just here's a collection of spreadsheets, and you got to interrelate them in this way, and you can't have too much data in one bucket or all this. It actually makes you think about how your data is stored. It brings you down to that level and how it's accessed and what your efficiency is going to be, what your network cost is going to be for any given call. And so instead of thinking of it as a single modal database, it's really a database construction kit. So you have all of these different features and data types available to you to build pretty much whatever your heart can imagine, or your employer's heart can imagine, as the case may be. Much like anything else, I'm a technologist first and a salesperson second. So you really want to use the best tool for the job. I'm not going to say that Redis is going to solve all world hunger and everything like that. But it is very flexible, and you can do an immense amount of things with it. And so the goal of this talk is really to try to talk about some of the less obvious things that you can do with Redis. And so, on that note, let's actually get into it. As I mentioned before, it's a key value store. The keys are going to be a very important part of the way you structure your data. And so a few things to keep in mind. You are limited to half a gig. I really hope that's enough for you. You generally want to avoid these really, really long names because it's all taken into consideration with your RAM. It's not like a SQL database where that's kind of baked into the way that the data is being processed. And then the flip side of that is also true. Like, you don't want just U, an ID, and then R, right? Because your schema is really dictated by the way that you structure your namespace. So you have to do so intelligently. It's the same way that you would treat variable names in your code. And although it's not mandatory, the general convention that you'll see if you look at open source code utilizing Redis is colons to separate different ideas or entities within the database key name. And like I said, make sure that your key names are in order because that's really what's going to dictate your structure in your application. These are some of the more common use cases. I'm not going to talk about most of them in detail. There are a plethora of Stack Overflow articles. We've got many white papers online that explain how to do stuff like this. And I want to say probably the majority of the people who are using Redis have done something like this. And of course, caching, which is where everyone pretty much always starts. And I'm going to talk about in a little bit our new module system that we announced about 6 weeks ago and how that essentially opens up a whole new frontier of options for you in terms of creating your own data types, your own data processing, so on and so forth. So strings are kind of the basic component that almost all the other data types are built on top of. It's the one that most people will start using, as I said, like in a cache. And you have the ability to store a few different kinds of data in there. So you have strings, obviously, and then you have integers. A lot of times people use like mutexes or locks across a distributed system using the integer command. If you're just really interested more in counting on a floating point number, you have that option as well. And then you have the ability to store binary data. So I think it's Instagram that actually tracks all of their login data using binary strings. For each user would have a key, and then for every day that they log in, they set a bit. And then using bit math, you can actually figure out how many users were online on a given day, how many times a given user is logged in, and you can do all kinds of interesting analytics as a result of that. Wait, wrong button. Okay, so here again is kind of your most simple and entry-level idea. This resembles Python. You may or may not actually work, but the general idea is that you're going to take a hash of your SQL, and then you're going to try to attempt to get that hash value as a key. If it doesn't return, you're actually going to hit your SQL database with it, and then you're going to set that value as your hash value. So that the next time that this function runs, it's going to pull the data from Redis instead of your SQL database. And then you have the option to set a TTL for that given key so that if your data is changing, I don't know, once every minute, once every 5 minutes, once a day, that it will expire and then refresh your cache. This is often referred to as memoization. And again, this is pretty much the beginning step for almost every single person that I know who started using Redis. The hash data type is a Redis within a Redis section. I hear you like key values and your key values. So it allows you to take what could potentially be separated across multiple different keys and aggregate them down to one. And then a lot of those same string operations that I talked about before, they're going to be available for each of these different attributes as well. So you can, this in some ways is kind of like syntactic sugar, because you're not really getting any kind of real performance improvement out of it, but it does make things a little bit more organized. So one way to think about this is for a shopping cart. Here, if you're going to add a product to your cart, you're going to take your session, which is where you're going to get your user ID, although it should be session.userid. Like I said, it resembles Python. It's not actually real code. And from there, you're going to add the product as the key within the key. And then set the quantity of that. If you're going to remove it, the inverse, and then you're going to set an expiration time on whatever that is going to work for whatever your business logic is for that. And then at the end, when the user is ready to check out, you just use the hgetAll command to pull all of that down. And so most of the time, given this use case, your data is transitory. You might track it for analytics purposes, but you don't probably really need to have a table filled with every single shopping cart that someone made and didn't actually check out with, right? So this is a way to do that in Redis, overall speed up your application, and destructure your data a little bit, which, oh, that's the slide after this. So here's another way that you can think about it. This is the idea that I was talking about a minute ago with tracking user login. So here is how you would take the join date from the hash, which represents the different attributes related to your user. You do a delta to see how many days have been since then. And then you would set that as a bit in user ID and the logins. And then to return that, you would get the whole bit array of that data. So this is what I was getting at just a minute ago. Denormalization is very common and oftentimes is another entry-level use case for using Redis. So this is not SQL. You are not going to have a countries table. It is very complicated to try to update multiple keys and having to remember to do that with every single operation. It's much easier and generally more efficient to just duplicate your data. So, and that's common in the NoSQL paradigm. Like if you look at some of the document databases out there, they're going to advocate doing roughly the same thing. And the reason why is because usually processing time is going to trump organization of data. And most of the time in that scenario, you don't actually really care too much about the country. It's just an additional attribute that's going to exist as a part of that data entity, right? So lists is another data type that's available to you. Most of the time you're going to see this used in key-based operations. It's implemented on top of a double linked list, so interacting with the header tail of the list is extremely performant in O of one operation. Trying to traverse the entire list, a little bit less optimal. In those situations, you might want to use a set unless duplicates or order is really important to you. In which case, if order is actually important to you, there's a sorted set, which we'll talk about here in a second briefly. So going back to the shopping cart e-commerce website option, or example, that's the word I was looking for. You could, for every product that a user has viewed, push that product ID into a list, and then you only really want to keep track of the last 10. So then with every page view, you pull that whole list down, and then you present it at the bottom of the page, showing the user what they've looked at, because A, they really wanted to buy that, but they got distracted, and now you have a chance to actually convert them in that sense. And this kind of operation would return usually in less than a millisecond. And using the enterprise version regularly, I get a million plus operations a second, a million and a quarter actually, with sub-millisecond latency. So you can do these kinds of things at scale with really little effort. And then, as I mentioned before, primarily lists are used for queues. Pretty much every programming language that I've actually looked into this before has some kind of queuing library that allows you to do distributed task processing that's using Redis as a broker. And the general paradigm of that is that you'd have your QID and then some kind of item, usually a GUID that's pointing to a hash that represents all the different data for a given task. That gets pushed into a queue. And then your worker task would pop that off, again, in one operation. And you have the ability to, using a VR or VL pop, depending on which end of the list that you want to interact with, that stands for blocking pop. And that's not going to block your Redis process, it's going to block whatever your client is. And so you can give it a timeout and say, okay, give me what's in this list. If it's not there, I'm going to wait for 5 minutes. And this is very common in these kind of consumer queue paradigms. And if you actually look under the hood at those libraries that I mentioned before, Rescue I think is probably the most common. It started as a Ruby library, it's ported over to pretty much every programming language that I've looked for, which .NET's Java, Python has an implementation of it, has a few actually. Sets are similar to lists. It's a collection data type. It allows you to have a unique set of items, and this is primarily used for indexing. So one of the common examples that I use is, say we're making a social media network. I'm going to have a hash for my user that's going to represent that user's name, email address, whatever I care about for that user, and then I'm going to have a set of their friends' user IDs. And then I'm going to have a list of their newsfeed. And this was actually one of the first really kind of high-scale use cases of using Redis was Twitter would put, for a given tweet, every user had a key, and they would put the tweet IDs in there. So rather than having this very complex multi-join query that they would have to run anytime a user logged in, they just pull that one list. And that made it so much faster. Because, and it's not even necessarily the read that made that complicated, it's the distribution. So imagine that you have, 1 million followers on Twitter. You don't necessarily want to have to, pull that information all the time. You just want to distribute it across that key, those different keys. And that's something you can do in a single transaction. 1 million keys, probably a couple seconds, especially if you're running on a highly performant or a highly optimized Redis cluster. So, as I mentioned, they're used often for indexes, and this is part of the reason why. So there's a few different commands in Redis that allow you to search your entire key space. The safest of those is the scan command. And by safest, what I mean is when you start running at scale, where you have multiple masters, each representing a subset of your key space, you're going to end up sending a given command to only a single shard. And there's a lot of different ways that you can kind of optimize that and how you can control your hashing algorithm to be able to manage that. So if you run, say, the keys star command, you're only going to get the keys from a given shard. You're not going to get it from the whole thing. So scan doesn't have that limitation. However, it is paginated. You are not able to get your entire millions of keys in a single result. And another thing to keep in mind is that Redis is single-threaded. So if you have very expensive operations that you're running against, you're blocking it for the entire rest of your application space. And that's usually not a good idea, especially for something that is advertised as very, very fast, which I probably have already mentioned once or twice. So instead of actively searching your key space to try to find information, it's usually better to try to build your own indexes for things that you're going to need. And there's a couple different data types that are really good at that. Sets are good if you don't have any kind of relationship with these different data entities. So going back to what I was saying before, if you have a set of friend IDs, you could potentially go get all of the different keys that represent a given user all in a single transaction. Then, and you could also do this server side with Lua or the new module system, you could pull this and then pull all of the user's friends and then return that all as a single large block. And that's going to run in probably, 10, 15 milliseconds? Performance may vary depending on how good your Redis implementation ends up being. And if you hire me, it'll be great. So here's the basic usage of that set data type. You would just append or add the given user ID to this country ID. So before I was talking about data denormalization, how you probably don't care about the country's attributes so much, you just want it so you can do some localization analytics later on in the back end. So here's those analytics. You have the ability to go in and put all of the users for a given country into an index, and the next time you want to see, okay, who are all of our users from Paraguay, or insert country name here, you have the ability to do that in a single call. It's going to return in a millisecond. Build application on top of that, your BI people are going to be so happy with you. Oh my God. So, and here's the inverse of that. This is how you pull that same information out. So, if you're familiar with set operations in given insert programming language here, you're probably familiar with cardinality, intersects, differences, and unions. Here's some kind of different ways that you could do some presentation layer representation of your user's data with very simple single commands at scale, very quickly. Sorted sets are basically like sets. You have a collection of unique IDs or unique string names, keys. Those are sorted or associated with a numerical value. So usually what you'll find these being used for is some kind of analytical tracking or reverse indexes. So say you have all of your users with some kind of numerical ID or a GUID that can eventually be reduced down to a numerical ID. You can store things about them, these different keys, by these IDs. and look that up and actually run ranges and a lot of the same kind of operations that I showed you before. Those same operations are available for sorted sets, and then it has additional ones that allow you to do, alphabetic sorting and ranging over your key or your scores. And if you're interested in these, we have an ebook available on our website, redislabs.com/ebook. It was written by Dr. Josiah Carlson. He spends like half the book talking about things you can do with sorted sets. It's actually really fascinating. I highly recommend it. And oftentimes, you want to count things. A lot of times, you don't necessarily care what the things are. So in that situation, the HyperLog log data type is really helpful. So it allows you to keep track of a collection of unique items and find out the cardinality of that set. Cardinality means the number of things, for those of you who don't know, because I didn't until fairly recently. And it also allows you to do these same kinds of set operations. You can see what is for a collection or two different HyperLog logs, what is the overlapping unique cardinality of those two sets. And this is extremely performant and memory efficient. You can track billions of items in about 12 kilobytes of data space. And then is Redis ACID primarily? Mostly, kind of. Depends on how you use it. And it offers you the ability to do something resembling transactions. The tricky thing with these, though, is, as I mentioned before, Redis is single-threaded. So if you issue a multi-command, you block that thread for the entire application space until the exec command is run or a rollback command is run. This deck's a little old. We actually do have rollbacks. You can do Lua scripting, which allow you to do some kind of stored procedures, which make these transactional logic a little bit more interesting. Because if you're pulling and going back and forth over your network, you're blocking Redis this entire time. Your entire stack hates you, and that's just bad. So we also now have modules, which I'm going to talk about here in just a second, which are even more performant than the Lua scripts and allow you access to anything in the C library. So you can build very, very complicated applications doing that. And of course, much like anything else, whatever you want in your application is going to be a trade-off. So if you really need consistency over, say, availability, you can use the wait command, which will block until all of the different replicated Redises that are pulling off that given master have said, okay, we're in synchronous. There's a lot more that I didn't talk about. This is kind of a quick overview over the different data types, hopefully to inspire you to think about Redis a little bit differently than just caching. But there's also PubSub. You can do various different kinds of expiration and eviction that applies to your entire key space rather than having to manually set specific time to lives on your given keys. You can do server-side scripting with Lua and with modules, which I'm going to talk about here in just a moment. And it has replication availability, and you also have the ability to be persistent and do backups. If you treat it like a real database, it can be a full-fledged database. And I know a handful of companies that have taken the plunge on that, and it's actually kind of cool. It follows the same sort of paradigm as Node does, which if you're writing Node for or writing JavaScript for your front end, you're writing JavaScript for your back end, you don't have that context switch, which takes time. And I'm assuming most of your programmers, context switches are the bane of our existence. I hate meetings for this reason. So if you're using Redis for your entire data stack, you don't really ever have to think, how am I going to represent this in SQL? What does my schema have to be? And that makes development faster, which I'm all for, being Python programmer. Okay, cool. I want to ask, are there any questions before I get into this? Take like maybe one or two. No? Awesome. Okay, so modules. We just announced about 6 weeks ago at our conference that there's going to be a low-level C API opened up. It's currently in beta. It'll be released this quarter with the next major Redis release. And this allows you to run even more complicated and immensely more performant stored procedure-like things server-side. It's going to be future compatible. This is why he's being very careful around the way that he's releasing this. Mostly written in C. You get a lot of the same performance that you can get in the core. Like I said, it's going to be released here in this quarter. And the reason why he chose to do this is because Redis has reached a certain level of maturity where once any given software, not just open source, but any given software reaches a certain level of maturity, your desire for any given iteration stops being less around adding new features and more about how do we make it more stable, tighten down the screws, right? And so that's kind of where Redis is at, and it's reached that agency moment where he really doesn't want to add additional features, not really. I mean, he will, and but this essentially allows the community to add their own features and not be bound to the open source development cycle. And Redis Labs is actually going to be offering a marketplace. So if you develop a module that everyone likes, you can make money off of it, and everyone wants that. So the main thing that you can do with them is it allows you to process your data wherever it is. You can do functional composition, create interesting and complex data pipelines, as well as write your own data structures. As I mentioned before, you have all these primitives available to you. These are the same things that you learned in Data Structures 101. You could build a binary tree that's built in, or even much more interesting and complicated, what's it called? KTOP, probabilistic data structures, similar to the HyperLog log, but more specialized for a given use case. And it's built on 3 different layers. So you have operational, which is going to be your administrative commands, tracking. This, if you wanted to build a really efficient monitoring plugin, that's the layer that you'd interact with the most. Then you have the high level and the low level. High level is going to be, it's the difference between Python and C, right? Like you won't have to do as much low level work if you're using a high level API, but it's not going to be as performant. And then low level is, of course, the inverse. You have almost native access to all of the different types that are available to you at the core level. And you have more granular control over the memory of that as well. So why would you use it? It makes everything faster. If you're using Python, you can do this operation in about 1.2 seconds. Lua is a little bit slower. I don't entirely understand why, but I'm taking my developer's team's word for that. The high level, you can do it a little bit faster than Python, but the low level, look at that. And I feel I should mention like 76% of statistics are made up on the spot, so take this with a grain of salt. Here's essentially the hello world for a Redis module. And there's a lot going on here, and I'm kind of running out of time, so I'm not going to go through it all at a low level. But the main thing to bear in mind is that you have the Redis module header, and then you have to structure your functions in a certain way. There's also a certain way that you need to compile them, and then you would actually start Redis using an additional command as well. But once you have it in your Redis running and you have that module loaded, you have the ability to do example echo bravo, which is, again, essentially hello world for this context. But you can understand, especially if you combine these different data structures, wouldn't it be neat if instead of having to pull and take care of all of my indexes with every single insert and update, I just call a module command that does all that for me and takes some serialized data or some collection of arguments, and I don't have to think about it as an application developer. I let the data people deal with that. If you're interested in hearing or finding out more about this YouTube video, and I think these slides are going to be available online. Yeah, so you can find this online. This YouTube video, our head developer advocate gave an hour-long webinar, I think like a week or 2 ago, and some of the slides that I just used came from there. So he talks in a lot more detail about how to use the module API, what to do with it, and so on and so forth. And then one last thing, kind of as a teaser for another talk that we're doing here. Redis has a Spark connector. So this is a normal Spark architecture, right? You pull data out, you do stuff with it, then you push it somewhere. Using the Spark connector, you can pull data out, import it using the native RDB data types, and export it using those same RDB data types. So much like anything else that I'm saying, Redis is really, really fast. So this is why you use it. You can get about 100x performance improvement over using HDFS, and about 10x performance improvement using Spark in memory, just the native Spark in memory, or the Tachyon process. My coworker, Dave, is going to be giving a talk talking in a lot more detail about the Spark connector at 4:50. It's also on the NoSQL track, so if you're interested in hearing more about that, check that out. Otherwise, thank y'all. Appreciate your time. And if you have any questions or you want to dive more, I'll be up at our booth for the rest of the day.
Well, I have some stickers here.